Hi, in exercise P2 we are to find the cheapest possible system for driving the centrifugal pump. Please note that the place of installation of the pump is wet, meaning the electric motor coupled with the pump will have to have a special degree of protection. As for the frequency converter, it will be installed in a clean electric room, so no special protection is required. In this exercise we will ignore efficiency and will focus on cost only. We will have to design two systems basically, the one for the case where the pump is working at its rated point, and another case would be when we know the pump is never going to be loaded above 80% of its rated load. In both cases we'll have to carry out optimization of the drivetrain on cost and then present the final design, writing down the types of the motor, the frequency converter and the cable, and present the overall system cost. Design of the system for the rated operation is pretty straightforward, so in this video we'll focus on the system design for the case with 80% maximum load. We know that the load curve of a pump is quadratic, meaning torque is proportional to speed squared, and that means that power is proportional to speed in power 3, which in turn means that 80% load, 80% power corresponds to some speed which is lower than the rated speed. So if we limit the power, that means we limit the speed as well. Now let's look into the sizing software. So we choose the simplest topology without gearbox and transformer, and for the entered pump parameters we pretty easy find system design, which we can optimize if we tune parameters of the components. So we see the overall system price here, 35,000, and what we are after is power on shaft. So this is the power required from the motor side to drive the pump in rated operation. So now we can design the system for 80% load case. We know now the power is 97 kilowatt and the speed should be lower than the rated. It can be approximately 1350 RPM. Let's now try to make the changes into the parameters of the pump. So reduce speed and 80% of head, that will lead to 80% of the pump power. So we see that all components are chosen, so everything is fine, and we can go into the report, and here we can read up all the necessary parameters for reporting. So now you can read up on the type of the motor and the converter, as well as their costs and overall system cost into your table for your report. That's it.